Assalamualaikum and good morning. My name is Ali Hafiz bin Ali Hanafia. My metric number is CB210353. Today I would like to present about my e-portfolio for hatchback water treatment. For the first, I want to talk about my student profile. My name is Ali Hafiz bin Ali Hanafia. My metric number is CB210353. For this year, I'm 22 years old. I'm studying in University Terusan on Malaysia. I'm studying for bachelor degree in refrigeration and air conditioning with honors. This is my portfolio. It is summary for my subject hatchback water treatment BBZ20706. This is my introduction. Hatchback water treatment is vital for maintaining efficient and reliable heating, ventilation, and air conditioning system. Is involved process like filtration, chemical treatment, disinfection, and regular maintenance. By removing impurities and controlling water chemistry, hatchback water treatment prevents scale formation, corrosion, microbiological, and fouling, which can lead to system breakdown and health hazard. Proper treatment improve system efficiency, extend equipment lifespan, reduce energy consumption, enhance indoor air quality, and minimize maintenance costs. Building owner, facilities manager, and homeowner can optimize hatchback system performance and create a comfortable and healthy indoor environment. By implementing effective water treatment strategies and adhering to regulation and guideline. The first mind map is hatchback open system. Type: open recirculating system similar to closed recirculating system. Repeatedly utilize the same water while being exposed to the environment. As the water flow over the tower, evaporation occur and releases the heat absorbed during the process. The cooling tower water then return to the heat exchanger to absorb more heat. For the specification, first the recirculating water pump, second the heat exchanger, and the third one is the cooling tower. For example, cooling tower will go to water pump and is going to heat exchanger, and from heat exchanger going back to cooling tower, and the process will repeatedly. For the second mind map is hatchback closed system. For the type number 1, a closed recirculating system is also known as a closed system. Second, it use a fixed amount of cooling water that is kept separate from the atmosphere. Number 3, the system goal is to withdraw heat from a process without losing any water. Number 4, early engine design inspired the concept of closed recirculating cooling water system. For the specification, number 1, closed recirculating system is aquaculture recycle and reuse water, resulting in reduced water loss and the preservation of water quality for aquatic life. Second, the key features of closed recirculating system include continuous water recycling, minimal water loss, and the maintenance of water quality through filtration, aeration, and treatment process. For the example, it's like in this diagram. For the first, from heat exchanger going to heating or cooling equipment, and then going to pump. The process will be repeated. For the third mind map is common cooling system problem. We have 4 common cooling system problem. The first one is corrosion, second is mineral scale, and third one is microbiological, and last fouling. For corrosion will be in our system because have moisture, oxygen, chemical, pH imbalance, and lack of corrosion protection. And how to prevent it? The first one is use corrosion resistant alloys. Second, adjust system pH scale. third is apply protection coating. The third one is apply chemical corrosion in highlights. And for mineral scales is because mineral variation abound in cooling tower. The mineral is often poured into water. Mineral may emerge from solution to create scale, which are true thick crystal if the right condition are present. And how to prevent it is the first, limit concentration of scale. Forming mineral blow down. Second, put chemical scale inhibitor to use. The third one is feeding acid lowers pH and alkalinity. And last, chemical design change. And the third one is microbiological. The causes is microorganism, source is air or makeup water, and cooling system provide the ideal environment for microbiological growth. The example is nutrient, ammonia, organic contaminants. For temperature is 70 to 140 Fahrenheit acceptable. For pH is 6.0 to 9.0 ideal. Location, light or no light. For atmosphere, aerobic or anaerobic. How to prevent for microbiological is water quality, eliminate organic contaminants, no bugs, system design concentration, system clean basin, plastic cover deck, chemical treatment with biocide. The chemical is oxidizing biocide, non-oxidizing biocide, and biodisperate. And last one is fouling. Fouling is because have dust and debris. Second, biological growth. Third is scaling and mineral deposit corrosion, chemical reaction, improper maintenance. And for the prevent, the first one is step taken to prevent foulants from entering the cooling system. Second, good control over the clarification of the makeup. The third one is good control of corrosion, scale, and microbiological. For the fourth mind map is treatment program for closed system. For makeup water requirement, for system type and requirement, high temperature for hot water is softened and decreated. Medium temperature for hot water is softened and decreated too. Low temperature hot water less than 100 ppm, hardness as CaCO3. Chill, brine, and glycol is less than 250 ppm, total hardness as CaCO2. Diesel engine jacket, for requirement number 1 is less than 50 ppm, hardness. Second is demineralization when brackish water is used. For selection guidelines, system type and treatment program. For high treatment hot water, sulfide caustic. Medium temperature hot water, sulfide caustic. Low temperature hot water, number 1 sulfide caustic, number 2 nitrite azole, number 3 molybdate azole. Number 4, nitrite molybdate azole. And system type for is chilled brine and glycol. For treatment program, number 1, nitrite azole. Second, molybdate azole. Third one is nitrite molybdate azole. For diesel jacket, diesel engine jacket is for treatment program is polycyclate azole. And microbiological control guideline, bacteria type, total aerobic bacteria, colony forming units is less than 10, less than 10. Bacteria type, sulfite reducing bacteria. For colony forming units, undetectable. Bacteria type, sulfite microbiological, colony forming is less than 10 to undetectable. Corrosion control program, the chemical using is sulfite caustic soda. Number 2, nitrite azole. Number 3, molybdate azole. Number 4, nitrite molybdate azole blend. Number 5, polycyclate azole. And this is for our case study. Our case study, we are going to Pusat Perubatan Universiti Malaya or PPUM for site visit. During the site visit, we must measure pH, conductivity and hardness. After take the data, we must also compare the data before and after service. After that, we must take the data to make analysis data for comparison to insert in our report. For conclusion, HVAC water treatment is vital for optimal HVAC performance, energy efficiency and durability. Professionals utilize water analysis, chemical treatment, filtration and monitoring to manage microbial growth, prevent scale and corrosion, and maintain clean water. Appropriate treatment offer extensive benefits such as enhanced system efficiency, reduce operational express, minimize equipment failure risk, and prolong HVAC component lifespan. Furthermore, it promotes better indoor air quality, creating a healthier and more comfortable environment for occupants. As technology advance and environmental concern grow, HVAC water treatment become increasingly important. We can further improve HVAC system efficiency and environmental sustainability by adopting sustainable practice and improve solution. Thank you.